Hey guys, Mr. Mackey here. Now yesterday I was showing you linear sequences, which are sequences that either go up or down by the same term. So if it was a linear sequence where it goes up by 6, it will go up by 6 every time, or down by 6 every time. And I showed you this rule, 6n plus 5, and I gave you 3 numbers. Now only one of these numbers is part of this sequence, and the challenge I set you was to find out what was the number. So here's how you do it. What you do is, you know that you're timesing 6 by a term and then you're adding 5 to get to 126. All you need to do is reverse the process, sort of like balancing, like we did with Algebra Week. And when you then get the answer of n, if n is a whole number, it is part of the sequence. So let me show you what I mean. So 126 equals 6n plus 5. Let's start by balancing by minusing 5 on both sides. So once you've done that, you'll end up with 6n equaling 121. Now you divide 121 by 6. And you will get a fraction, not a whole number. So this number is not in the sequence. Let's now try to 304. So 304 equals 6n plus 5. Let's now balance it by minusing 3 on both sides. And then once you balance it, it will become 6n equaling 299. Let's now enter this in our calculator. 299 divided by 6, and you will get another fraction, not a whole number. So this is not in the sequence either. So by process of elimination, we can conclude that 251 is part of the sequence. But let's just be sure, because there could have been a mistake. I might have said none of them are. I've done that before. So what you need to do is you need to balance it by minusing 5 off both sides. And that will become 6n equaling 246. So let's divide 246 by 6. And that will get you as n 41. That's a whole number. So 251 is the 41st term in that sequence. Now, we're going to be doing another lesson on linear sequences today, but we're going to go a bit more deeper. How? Well, I'll show you this. So I have a sequence, 5, 9, 13, 17, 21. And I want to find the 100th term of this sequence. Now, there's 2 ways to find the 100th term. The very long way, which is we just keep on going until we reach 100. That'll probably take longer than this video, and you might get bored, and you might even lose track, and you might not even reach 100. You might just completely lose count. There's another way though. And that other way is that we use a rule and substitute that 100 instead of the n, and we can use it to find the 100th term from there. But there's one problem. We don't have the rule. So today's video is going to be how we can create and find the nth term to solve problems like this. Let me show you how we do it. We'll get back to this sequence in just a minute, but let me show you an example right now. So here is another sequence for now. 4, 8, 12, 16, 20. Those are the first 5 terms. Can you notice anything about this sequence other than it goes up in 4s, which is important? It's the 4 times table. So for the first term, it's 4 times 1, 4 times 2, 4 times 3, 4 times 4, and 4 times 5. You're probably wondering, why have I circled the 1, 2, 3, 4, 5? Well, that's because that's the same number as the term that the sequence belongs to. So for the first term, it's 4 times 1 to get us 4. 4 times 2 to get us 2. Okay? So, how do we find the nth term, term n? Well, you just times 4 by n. Because that's what you're doing to all the others. And that will get us 4n. You could write it as 4 times n, but that's just a neater way of putting it. So, if we have a sequence that's the 4 times table, then the rule, or the nth term, is just 4n. If we had a sequence like 5, 10, 15, 20, 25, which is the 5 times table, then the sequence for that would be 5n. Because we're times, because remember, if the first term is that, and for the first one we're doing 5 times 1, 5 times 2, then it would be 5 times n for the final part. So, that's a handy thing to know. So wherever times table is, you just do the times table times by n. 4 times table, 4n. 5 times table, 5n. Let's now go back to the sequence I showed you just now. So this was the sequence we just looked at. 5, 9, 13, 17, 21. Now, to find the nth term of this sequence, because this isn't a times tables, I ask you 3 questions. Question 1. What is this sequence going up by? So, if you look, the difference between 5 and 9 is 4. 9 and 13, 4. Well, because it's linear, it will always go up by the same number. So this sequence is going up by 4 every time. So that's question 1. It's going up by 4. Question 2. Which sequence also goes up by 4? Well, if you looked at the one I just did with the times tables, the 4 times table goes up by 4. Remember, 1 times 4 is 4, 2 times 4 is 8, and that's also known as 4n. So I'm going to write 4n under here. So term 1 is 4, term 2 is 8, term 3 is 12, term 4 is 16, and term, no idea why I did a curve there, and term 5 is 20. So that sequence also goes up by 4, but the problem is they don't match. They're not the same. So my final question is, how do I make 4n match the sequence above? What must I do every time? Well, to get from 4 to 5, you add 1. To get from 8 to 9, you add 1. 12 to 13, you add 1. 16 to 17, you add 1. And so on. So the rule of this sequence is 4n, the 4 times table, add 1. And that's all you have to do. Let's try another one. Now I have this sequence, 5, 11, 17, 23 and 29. And I want to find the nth term. So I first ask myself, what is this sequence going up by? It's going up by 6. Every time. So question 2, which sequence also goes up by 6? Which times tables? Well, the 6 times tables. And that 6 times tables in sequence form with the nth term is also known as 6n. So my final question is, how do I make this sequence the same as the original? So how do I go from 6 to 5? You take away 1. 12 to 11, take away 1. 18 to 17, take away 1. 24 to 23, take away 1. 30 to 29, you take away 1. So the original sequence is 6n minus 1. That's all you have to do. Let's do one more before the challenge today. Now this sequence isn't increasing, but it's decreasing. But how much by? Well, it's going down by 3 each time. We're minusing 3 each time. Now, which times table also goes down by 3? Well, the 3 times table goes up by 3. So the times table we're looking at here is the -3 times table. So -3, -6, -9, -12, -15. So it's -3n. So how do I make them the same? So how do I get from -3 to 50? You add 53. -6 to 47, you add 53. -9 to 44, add 53. -12 to 41, add 53. And -15 to 38, you add 53. So the actual rule is -3n add 53. Another way you could write it is 53 minus 3n. It's a way to line it up. Now, let's see how you can do with this knowledge on a challenge. I have a sequence 4, 11, 18, 25 and then 32. And I want you to find for me the 100th term. You can do the long way, but I definitely won't be showing you how to do it with the long way in tomorrow's video. So I strongly recommend you find the nth term first and then find the 100th term from that. It's the quickest and, quite frankly, easiest way. I'm looking forward to seeing what you think of this. We'll be looking at a whole new type of sequence tomorrow. Can you figure out what this sequence could be looking at? Can you figure out what it might involve? I'm intrigued what you've got to say. Keep on practicing these, keep on learning, and I cannot wait to see these results tomorrow. Have a good day, guys. See you on Wednesday. Have a good day, guys. See you on Thursday.